In this section, you'll learn how to write a script which will essentially serve as a real easy way to monitor network connectivity between host A and host B. Now, host A can be a Linux box on your network. Host B can be a site such as Google, or maybe your default gateway, or just somewhere else on the network that is a critical point in determining network accessibility. So let's open a shell script and begin scripting away. Now, all of our scripts are in temp 2, and as you can see, we have a few things here, including move many, which we worked on recently. Let's give this new script a name. We'll touch a new script, and let's call it, for example, network checker.sh, and we'll modify it network checker.sh. Now, whenever writing scripts, it's a good idea to use a separate tab, a separate window, so that you can test some of the commands that you plan on including in the script. You also need to determine what you'd like to put in the script, so you can test them in a separate window to see how they would behave in the script, thus increasing the speed of writing your script. We do the defaults always. Must have a header. Optionally, you can put the author information. That's all optional, of course, but you should, including date, etc., and purpose. And we'll put a purpose. We'll say this script monitors internet connectivity, and in the event of problems, it can email the administrator. And we'll have our end statement, and in between we write our script. So first and foremost, we want to think about some of the variables and some of the things that we want to do. Now, we can write the script in any order. We don't necessarily have to define variables up front or write in any order. We can write ad hoc and then rearrange the order later. That's the beauty behind shell scripting and programming in general. So we've determined that, for example, internet connectivity at our site means the ability to get out to a site such as Google. So first and foremost, try to ping Google. So try to ping www.google.com. In the event that we're able to get to Google's website, internet connectivity must be good. So we're getting a response, but the first thing you should notice here is that the ping, the behavior of ping within a Linux environment is to send ICMP outbound packets, echo packets, indefinitely. So if we don't control C or break this process, it'll keep pinging. So how do we alter this behavior? Simple. Ping accepts an argument, the -C argument, which really stands for the count for the number of packets that are to be sent to the host. So a number such as 3 or 2 is sufficient. 3 is typically preferred, but 2 is fine if you typically have good network connectivity and are using this just as a backup. When you send 2 packets, that should tell you whether or not things are working. Now, immediately after having run, as is the case you've seen thus far with all shell scripts and all programs within a Linux environment, the exit status is available. Now, we've yet to run another command, so the exit status is certainly available within this shell. If we echo it, it should say 0. Now, let's prove that the exit status is correlated or corresponds to the success or to the return value of ping. Let's try to ping a bad address, something that doesn't exist, an address we've used before, such as 1.34. This is a host that doesn't exist on the system. After having pinged this host, let's echo the exit status, and as you can see, it's 1. So this should serve as a simple enough test and a reliable enough test for us to determine network connectivity. If we're able to ping a host, such as Google, who accepts ping, then we have good network connectivity. If not, something's wrong. Not all hosts on the internet accept ICMP echo packets, so don't solely rely upon ping as your tester. Use alternate methods such as telnet. You could telnet, for example, or in your script build in some sort of telnet into, let's say, the web port of a popular site such as CNN or Google or Yahoo, and use the exit status from that particular command to determine what to do. But for now, we're going to use ping because Google accepts ping. Excellent. So let's go back to our script. The first thing we want to do is we want to run the ping command. and we want to send 2 packets out to www.google.com. Now we're not interested in the output. We don't care about the output, and as I've shown you before, if you don't care about the output, send the output to /dev/null. And you can test this at the command line before doing it. Let's ping Google with 2 packets, and we'll send the output to dev null, and we'll echo the error level once complete. Let's echo the exit status. You can see it's good. Excellent. So we've sent the output. We've suppressed the output by sending it to dev null. So now we have at least an exit status that we can test. Now, of course, we need a condition. So if, and we need to test the exit status. If the exit status is not equal to 0, because we're typically interested in when it fails, since the connection is up more than it's down. If it's down more than it's up, then something's wrong with your connection. You should reevaluate your connectivity. So if the exit status is not equivalent to 0, then we know something's wrong. Then there's cause for executing this particular condition. Then we want to perform some sort of function here, and we can echo, we can send an email, whatever comes to mind, but we'll begin with a simple echo. Echo, there may be, or there seems to be, internet connectivity issues. And then we'll end the logic. So we ping, we take advantage of the exit status, and we make a decision of what to do. Now this is a simple ping script. It's not logging, it's not sending its output anywhere. Nothing's happening yet. There are quite a few things we can do here, such as including the date. It's not simple enough just to echo there seems to be internet connectivity. We should also output the date. It's a good idea to output the date. And we can get the format simply by using command substitution. So if we do echo, then command substitution date plus %f, and we'll escape that. Or if you don't want to, you can keep it with no escaped sequence, but the date is fine. Typically failures are date-based. Usually you don't have multiple failures in a day unless you have poor connectivity. So we can begin with just the date stamp. If time is important, just use %r, lowercase r, and that'll work. So we'll echo the date. We'll also echo there seems to be internet connectivity issues, and this will get redirected to a log when it's all said and done, because we're going to run this particular script from a cron log. Now, we want to variabilize this a little bit more. We have ping running against Google, but we should set up a variable for the site so that we can change it at will. And this site could be sent from a positional parameter or from a predefined variable within. So let's define a variable. We'll call it site, and in this case it happens to be www.google.com. And then we'll replace this value here with the variable site. These are all things we've done already. So thus far we have comments. We've defined a variable called site. We're pinging that site with 2 ICMP echo packets, and then we're testing the error level. If it's not equal to 0, echo the date, and then echo there seems to be internet connectivity issues. Now the frequency in which the script runs will be determined by how we set it up with crontab, or with the cron program. Cron is the scheduler, the Unix scheduler, and the Linux scheduler. And we can initially set it up to run every 1 minute, and then change the frequency to perhaps something a little less frequent. Well, of course it depends on your connectivity. If it's poor, you should run it more frequently. Sometimes a simple script like what we've defined here is even good for VPN tunnels. For example, there are situations where, or sometimes you may find that tunnels need to be kept alive by sending packets, and sometimes the firewalls don't do a good enough job, but hosts on either end of the tunnel can keep the tunnel going by occasionally sending packets. So you could use this script and just alter it to include the IP address of the destination and simply ping that particular host on some interval basis. Now let's see what happens when we run this script. We'll exit, and we'll make it executable. and that's the network checker.shell. We can now run network checker.shell, and it's quietly sending the output to dev null, and then it proceeds. We can echo the output. This has run successfully. Currently nothing's down, and we are not logging anything. Now if you'd like to log internally from the script, you can. Let's show you how you do that. We'll modify network checker.script. You can log each line independently, or you can log the entire output of the script. That's quite possible as well. I prefer to log the output of a script rather than including line by line logging, such as log dot the name of a log file. Let's show you how that would work. You would run the script, and then you just send the output to a file. Now we're going to create a new file called log. Let's call it ping log. And this ping log will have a suffix of today's date. And we can do that by invoking command substitution. We'll just do +%f, and this will suffice. Actually, capital F, this will suffice. And close backticks. Let's see how this works. So it's running quietly, and if we do a lsltr, we'll see that a new file has been created, pinglog.2004-08-28, but it contains nothing because we're not echoing anything from network checker unless there is a problem. Look at it again. Network checker will only send something. The condition is set so that if it's not equal to 0, to echo the output. So how will we get this thing to echo output? Well, we need to put a bad site in for the site variable. Perhaps we can pass it in with a positional parameter or whatever. Now, you can also use multiple parameters to drive the ping. You could set up an if conditional which says if no positional parameter, then site is equivalent to www.google.com. Let's look at that. We'll say for here so that this script becomes more portable and runnable from the command line as well. So we'll say if open brackets, and we know how to export or to harness the value of positional parameter. So if positional parameter, no positional parameters, but in this case we want positional parameter 1, but if no positional parameter, if positional parameter is equal to 0, and we can just do it's a numeric, an integer, so we can do equal in this way. If it's equal to 0, then close brackets, then site is equal to www.google.com. Else, and we'll just tab this out, else site is equivalent to the positional parameter number 1. This should be quite simple. Not too much logic here. So we have logic up top for whether or not, or to capture whether or not the user has specified vis-a-vis positional parameters a site to ping. But if no site, so if the positional parameters are empty, we could even more specifically check for positional parameter 1. If positional parameter 1 is equal to 0, so if nothing's there, then site is equivalent to www.google.com, else site is equal to the positional parameter number 1. Let's look at this in action. So network checker will attempt to run, and let's just double check what site is set to. There's some logic problems, and it doesn't like the equal unary operator. Let's pico it. And the positional parameter here, we should be checking for all if none exists. Excellent. So this works. If nothing, then use Google. Send 2 packets out to Google. So if the positional parameter is equal to 0, then site is equal to Google. Else site is equal to 1. Now we should just include the positional parameter within quotes so that the words that are on the command line doesn't get split. We don't want it to get split. So let's just put the comparison within quotes, and the logic looks pretty clean. If equals to 0, then use Google. If not, use the site that's submitted. Let's go to a shell, clear screen. We'll run network checker. Now, there are no parameters. It won't complain. It'll simply use Google. And if we lsltr the ping logs, you'll see that it contains 0 bytes. Everything's good right now. No cause for concern. Now let's run it with a positional parameter such as our default gateway, and this should work well. No cause for concern. How about for a bad host? .34. This host certainly does not exist. And you can see the output here. There are connectivity issues. Here's the output. There are connectivity issues because 34 is not available. Now this output was not sent to the ping log. In order for it to arrive in the ping log, we need to actually echo it using the format we showed before to the ping log. We need to send the output there, and we'd simply call this ping log. Well, we can make use of command substitution for the date. So we'll say ping log dot open backtick date plus percent capital F close backtick, and this should work. And we have that on the wrong commands for network checker. Ping log dot date plus percent F close backtick, and this will send the logged output here. Now if we lsltr, you'll see ping log contains values, and those values include the date. We could have included the timestamp with %R, and there seems to be internet connectivity issues. That's when, of course, we use an invalid host. But when we use a valid host, it'll reset the size of this file to 0 because the valid host exists and there are no connectivity problems. Now, if we wanted this to run automatically, we could simply put this into the cron tab, and then it would run, let's say, every minute or so. Another way we could output this information would be to define a wrapper, like a separate file call the same name, like networkchecker.cron, which outputs all the information, and then have the cron tab call that cron file. Now the cron tab, the default cron tab is located in /etc, and you have a few directories. You have cron.daily, hourly, etc. Depending on the frequency that you want to run this particular script, you could just put the script in those directories, or point it to the script in those directories, and network checker would run. But the bottom line is we have the logic necessary for running network checker. So the logic is here. The default is to go out to Google or go out to the site specified by the positional parameter number 1, and if there are problems as returned by the ping command, echo this information. If you want more information from the data, as I mentioned before, you can escape a space and put a space between the date stamp and %R for the timestamp, and there seems to be internet connectivity options. And cron simply would control the frequency in which this would be run. And of course, we could have a last line in here that would send the output or some other output to the administrator. For example, we could cat the log file, which is log dot, and we could make use of the command substitution log.date, since we want this to change every day, %F, and if it actually has a timestamp, fine, but in our case we don't. So we want to send this into the mail command with a subject. Perhaps the subject could be there seems to be internet connectivity options, or you could variabilize this message so you can use it on the echo line as well as here. And close this, and then just send it to the root user. This would get sent to the root level user, and then the administrator or root user on the system would know about it. So this is a simple network checker script, similar to the move many script, but you'd be surprised at how simple the scripts are for managing things on your Linux system. Simply examine some of the scripts, for example, that are in etc and init.d on your Linux system, and you'll see that they're quite similar. So that's how we'd get an automated network checker going for using ping. You could alter it to do telnet or to check for ports, etc.